Hey guys, welcome to Unit 1.1. Today we're going to talk about what is a relation and a function and how can we evaluate function. So, a relation is a mapping of pairing of input with output. Think of input as my x, output as my y. A relationship, in other words, is just comparing two set of data, comparing the numbers I study with my grades on the regions, comparing the days and temperatures. Domain is a set of all input values, independent variables, and my x values. Range is the opposite, is a set of all output values, dependent variable, and y value. So a relationship can be in the form of an ordered pair, a table, or a graph. So in an order pair, remember when you write order pair, it's always x first, then y. So all these x would be my domain, all these y will be my range. Same goes for a table. All these x will be my domain, and all these y will be my range. Now similarly for a graph, you will pick a point. So let's say this point, this is 3, 1. And then it goes back. This is my x, that's my y. So I will get all my x as my domain and my y as my range. What about a function? A function is a relation in which for every input, my x value, there is only one output, which is my y value. So for every x, there's only one y. There are 5 ways that we're going to talk about how do we represent functions. Before we get into that, let's look at this example. In the first one, I'm given a table x, y. I don't want to see -1 goes to 3, okay, -2 goes to 5, -3 goes to 3, and -5 goes to -5. Notice that every x has one y value. It doesn't matter that 3 is repeated. It doesn't matter. X goes to one y value. So the first example, yes, this is a function. Let's go into number 2. 3 goes to -1, 5 goes to -2, 3 goes to -3. So since we have a 3 already, we don't need that. 3 goes to -3, -3 goes to 5. Notice this guy right here, 3. It went to -1 and -3. That's not our definition. Our definition say every x has to have one y value. So this second example is not a function. So how do we represent a function? Before we represent a function, we need to know, is it a function? So we need to do the vertical line test. A vertical line test, remember from Algebra 1, a relation is a function if and only if no vertical line intersects the graph of the equation more than once. So if you have, I don't know, let's just make an example up here. You have a graph that looks like this. When I do the vertical line test, it needs to hit the graph at only one point. So in this case, yes, that's a function. If I had something that looks like, I don't know, let's say a circle here, I want to know, is that a function? If I do my vertical line test, notice, see, it hits twice. That means this one is not a function. So 5 ways that we're going to represent functions are equation, something simple as y equals 2x plus 6. A table form, which we saw previously. A graph, we also saw that. A mapping diagram. A mapping diagram is just something right here, where you map your domain and your range. And an order pair, which we saw as well. Evaluating a function. When you evaluate a function at a value, you're just plugging in a specific value. So it's like somewhat of substituting. So f of x is equal to x plus 1. When I substitute a value of x, my input, I will get an output. Think of it as my function machine right here. Put in a value for x, and I will get f of x. Remember the correct way of reading this, okay? F of x. You got to be familiar with the words. So let's see how this works. A college equation. So this college function g of x is equal to 10h plus 40, where h represents the number of homeworks you did. When you plug in the number of hours you study, you're automatically going to get your grade. So the first one said, what if I study 3 hours? So my h is 3. All I'm going to do when I'm evaluating a function is substitute those values. So every time I see h, I'm going to substitute it with 3. This becomes 30 plus 40. This is 70. So if I did 3 hours of studying, I'm going to get a 70 in class. Perfect. Let's see. What if you did 6 hours of studying? So in this case, h is 6. Good. I'm going to substitute. So instead of g of h, it will be g of 6. Correct. This will be 10 times 6 is 60, plus 40 will be 100. So if you did 6 hours of studying, you're going to get 100. What if you did no homework at all? So in this case, when you do no homework, h will be 0. So g of 0 is 10 times 0 plus 40. 10 times 0 is 0 plus 40 is 40. See, so that's a simple part of evaluating. You just substitute the values. The last one for that says, what if I know that g of h is equal to 140 and I want to find, now it's asking you how many hours did this person study so that they can get 140% in the class. So I know what g of h is. It's 10h plus 40 is equal to 140 because it says g of h is equal to 140. I want to know what is the value when I plug this in here. What value when I plug it in there is going to give me 140. So this is a simple two-step equation, minus 40 on both sides. This is cancel. 10h is equal to 100. Divide both sides by 10 because remember this is multiplication. This is cancel. H is equal to 10, which is what I was looking for. When this person studied 10 hours, they will get 140. If you plug it back in the equation, you can check it really quick. 10 times 10 is 100 plus 40 is 140 what I wanted. Check. Now those are all the mathematical way. What if we got a graph? So this is an example of f of x equals 2x minus 3. Those of you looking at this, you should be able to see that this is a linear equation. It will give me a straight line, which is right here. I want to evaluate this graph at f of negative 1. So when I evaluate it, I want to plug it in. But now I have a graph. So I'm going to look at where is x. F of x is negative 1. Remember, this is going to be my input, my x value. Good. So this is my x value. Okay? So I look for negative 1, which is right here. And then I draw a line down to see where this, I can't get a line. So I want to draw a line to see where this intersects the graph. Perfect. So here we see that they intersect the graph at this point right here. And remember, you want the output, which is my y value. So I'm just going to come over and I see it's going to be at at f of negative 1 will be at negative 5. Again, I come down, look at the point, my x value, draw a line, and then look for where it intersects the graph. Good. Now I was told that find a value for x when, let's take this out so we can get, I know that some number, when I input it, I'll get negative 1. So this is negative 1 on my graph, and I want to see where does that, what value. So this is my negative 1, and I'm going to draw a line over. You could use the rulers if you want to draw a straight line. So I draw the line there because I know for some reason that this is my y value. Remember, this is my output. My output. So this is my y value. So I know my y value is at -1, which is right here. And I want to see what's f of x. What's this x? This is my input, my x value. So I draw a line to see where a graph intersects that line. And then I go up and I see it's 1. So solve f of x equals to -1 when x is equal to 1. So the key thing to remember is, are you looking for your input or your output value? Once you know which one you're looking for, we're all set. So one more thing before I let you guys go and practice is, what makes a fraction undefined? A fraction is said to be undefined when the denominator is equal to 0. So in this example, 6 divided by 7, take away x. What we need to do is set our denominator, in this case 7 minus x, equal to 0. We kind of ignore our numerator. We don't care about that because we cannot divide by a 0. So that's why we set this equation and solve your denominator and solve it for 0. So in this case, I will add x on both sides. This is cancel. 7 is equal to x. That's my answer. There's numerous ways of doing this. Remember, you could have started with -7 on both sides, but then you'll leave with -x and you have to divide by a -1. Either way, looking at this, we'll get the same exact answer. When x is 7, the denominator is 0, and it makes it undefined. One more example. So, in this case, my denominator, first thing, set it equal to 0. Y squared minus 2y minus 15 equals to 0. Remember, this is a quadratic because it has a power of 2, and that means we'll have 2 solutions, okay? So just like we did when we reviewed, let's start with what's my A, what's my B, what's my C. My A is 1, my B is -2, and my C is -15. Make my x A times C, which is -15, and -2 my B terms. Two numbers, when I multiply it, I get -15. When I add it, I get -2. Perfect. -5 and 3. Let's check it. -5 times 3 is -15. Check. -5 plus 2 is -2. Perfect. So remember from our last review, we would write this in factored form, which is x minus 5 and x plus 3. But remember, now we need that to make that equal to 0 because I need to find values, not x. Oh, perfect. Yes. One very common mistake, and as you can see, I did that. We need to not put x, keep the variable. So this should actually be y minus 5 and y plus 3. Perfect. Let's just make this minus a little better here. Good. Y minus 5. So remember, we need to set it equal to 0 because I'm finding two values of y. When I plug it in here, I'll get a 0. So this is where we kind of like branch off. We have two things here that we need to look at. Remember, as a quadratic, we're getting two answers. So we get y minus 5 equals 0, and I also have y plus 3 equals 0. If I was to add 5 on both sides, we get y equals 5. If I minus 3 on both sides, y equals -3. So notice I have two answers. If I was to plug in y equals 5 or y equals -3, we will make this denominator 0. And then this is normally a multiple choice question. They would ask you which of the following would make the fraction equal undefined. So undefined means my denominator is equal to 0. What you're going to do now is start working on portfolio 1.1. Once you complete it, place it in your binder. Actually, I need you to hold on to it in your UMKit binder. Should be coming hopefully this week, and we'll be able to organize our work. Keep it at a level 1. Please check it with me in the back if you need any help.